Hello everyone, this is Akash Chauhan, and in today's lecture we will continue with the function. In today's lecture we will discuss about the argument passing regarding functions. So either we can pass values of the variables or the address of the variables. So let's look at what is the basic difference between both of these methods. Okay, like we have discussed in last lecture that we will cover about call by value. In call by value we pass the values of the variables. Okay, the second approach is call by reference, or we also say this call by address. So in that case we pass reference or the pointer or the address of the variable. So by passing address of the variable, we are saying that this function can access the address of the variable. So if a function can access the address of the variable, and if function somehow tries to manipulate the values of the variable, then it is possible. Because why it is possible? Because we are somehow the function is you know able to access the address of the variable, as we are passing the address or the reference or the pointer of the variable. We will discuss with a particular example for each method. So let's start. So the first approach is call by values. So to understand call by value, let me first write a simple program so that we can understand the need of, first of all, the need of passing a value, and what will happen after passing the values to the function we are going to use. Okay, so like we have discussed this example earlier as well, that we have taken two variables a and b, and we are somehow trying to calculate the addition of those variables, and then after that we have replaced that code with the function. So the function would calculate it for the main method. Okay, so we write the addition logic in the function, addition function. Okay, so let me write the code first of all. So this is the code in which we have taken two variables a and b. We have initialized the values 10 and 10. Okay, and then we are printing the sum. Okay, in that case, okay, so this is, there is a little mistake over here. Let's not focus on this part. uh, Integer sum is storing the return value of add a and b. A and b is 10 and 10, and sum would be printed after the call the function is completed. So if you look at it very carefully, then some add is passing a and b. So here integer a will be stored in integer a, and b will store in integer b. And if you look at it, the values are 10 and 10. But after in the function we are changing the values. Okay, so what it will return? It will return 20 or 10, because we have changed the values. Look at it very carefully. We have changed the values. It may return 10 or 20. Okay, so in that case I would show you why it would return 10. Okay, because these are not actual values, these are the parameterized values. Okay, these are parameter of a function. Okay, parameters of the function. So these values are not same as these values. So we are not changing these values, actually we are changing these values in the memory. Okay, initially the values, these values are 10 and 10, but after this line the value would be updated to 5 and 5. So the result would be 10, not 20. Okay, but you must understand these values are same. 10 and 10, these values are same. Why? Because these values are stored at the stack at different location, and these values are also stored over the stack but at different location. These values and these values are different. Still, even if we are using the same name, okay, a and b, and a and b, still they would be stored at the different location at the stack. Okay, so let me take a memory example so that it would be super easy for us to understand what I'm trying to say. So let's say this is the memory. Okay, so the memory, this is a stack. let's say. Okay, so at stack A is stored as 10 and B is stored at 10. Okay, so after this, A would be updated to 5 and B would be updated to 5. These are these values. Okay, you should not confuse with that. These are these values, and the address for that is different. Okay, for these there would be a separate stack, or even if it is using the same stack, then these value would also be stored like this somewhere else. Okay, that's why this updation would not happen at the same place. Okay, so this is about the call by values. Okay, there are some important points as well that you must be aware about. So for example, the first point is copy of the values passed to the function. Okay, we are passing the copy, not the actual values. Otherwise, if the function would update the values, it means the original values would be updated. But we are not interested in changing the values, the original values the main method has. Okay, the second thing is the original values are not modified. That is what I have just discussed. The function parameters are stored in stack locally and separately. Locally means they are stored at the stack but separately. Okay, the function would also be look like this, but the memory, for example, this memory would be different. These are the original values. Okay, the copy of the variable will be passed. The last one is changes made inside the function will not reflect outside the function. So we are making changes inside the function. Okay, so these are actually the function parameters. So if we are making changes over the function parameter, it will not affect the outside function. Outside function is this area. Okay, so guys, this is about the call by values. Okay, but what if we want to change the original values? So this method is not appropriate because we are just passing the values of the variables. Okay, so if we want to make changes in the original values, then we have to go for the different method. So let me discuss that method now. This method is called call by reference or call by address, because in this method we don't simply pass the values, but instead of values we pass the actual address of the variable. So if a function has the address of a variable, then the function has this liberty to make changes or to modify the values itself, because the function can access the address of the variables being passed. Okay, so let me write a memory example for the same. Uh, Memory example for the same is I have taken the same example, but right now, at present, I am interested in changing the values. I want to make changes at the original location or original memory location. So for that, let me write a code, okay, so that we can understand how it is possible to make changes at the original memory location or the original values. So by this method, the original values will be modified. You must always keep this fact in mind. Okay, so let me write a code. Okay. Okay, so before writing a code, let's look at the basic definition first of all. So the basic definition is to make changes in the original values stored in the memory location. You need to pass address of the variable instead of passing values only. So if I want to make it 5 at the original value, then I should, what this definition is saying, you need to pass the address of the variable. Okay, pay little focus on this part. Pass address of the variables instead of passing values only. So in this method, we need to pass the what, the address of the variables. Okay, so let me write a simple code so that you it would be super easy for you guys to understand what I'm trying to say. So let's look at it. It is the same example I have taken, just little modification. So if I want to make changes at this location, I want to make it 5 and this also 5 at the original. So it means I should have the address. So the modification of A and B, is happening over here. Okay, then this function should have the address of A. So for that, I need to make this as a pointer because it can store the address, and again this b as a pointer. But if you are passing values, because a and b are the values, then it will not store. It is saying that a can store integer type pointer. It means a can store the address of an integer and b also the same. Okay, so for that we need to pass the address of a and the address of b. That is what we have just discussed. To make changes in the original values stored in the memory, you need to pass the address of the variables. Okay, so that is what we are doing. So the address of the variable will be stored over here. But do you think this code is enough and this will update these values? No. For that, what I need to do, because these are the values, a is zero point 0.5 and b, sorry, a is 5 and b is 5. For that, what you need to do, you need to add asterisk, because you are saying the address you have, you want to make changes at the value, so you are making change at a. So what I you are trying to say, you are saying I am modifying a, I am updating a and b over here. Okay, by using a asterisk operator, you can use, as we have discussed in pointer and function in the previous lecture, that if you want to modify the value, you need to use the asterisk value of a address. So a can store the address of a over here. They both are different things. So even if this function would return 10, okay, but it would, and the previous function, if you remember, that function was also returning 10. But what is the difference? The values over here are not modified. Okay, the original values were same, right? But in this case, if you pay little attention, the original values are modified by the new values because we have passed the addresses. Okay, so for that matter, let me write few points so that you, it would be super easy for you guys to keep things in mind. So let's discuss these points one by one. The first point is original values are modified as we are passing address of the values or the variables. Okay, the changes made inside the function will also reflect outside the function. Okay, because we are passing the address, it means the changes would reflect at the original location. Okay, so if thousands of functions are accessing the values, it means if the original value is being changed and the thousand functions are accessing the a and b and we have changed the value, it means the value would reflect everywhere. Okay, as we have made the changes by accessing the address. The last point is function parameters are also share the same space as the address are being used as function parameter. Okay, so previously the functions parameter were stored locally at the stack, but in this case they are sharing the same address space, this same space. Why? Because we are sharing the address. So if a function has the address, the function can modify, it has the liberty to make changes at the memory location. Okay guys, so I think this is about the today's lecture. In next lecture, we will discuss about the inline function and the recursive function. Probably it would be it wouldn't take more than 10 minutes. Okay, so the it would be the okay. So I should tell you that this would be the next lecture would be. I'm hoping the next lecture would be your last lecture of this unit, and after covering the next lecture, I would also create an assignment for unit 1. Okay, and I will discuss the solution after the deadline. And I'm also interested to have a doubt session before giving you the assignment. So in after the next lecture, I will also have a doubt session of unit 1, and then I will discuss about the assignment I will give you maybe tomorrow or day after tomorrow after the next lecture. Okay, and we will discuss about the solution, the hard problems in the assignment, and the doubt session. We will take a live lecture over the MS Team. Okay, so I think by that, if we go through by this process, I think your doubts will also be cleared. We will have a good assignment, so it will help you during your mid-sem and end-sem exams. And I'm expecting all of you would do the assignment very carefully and seriously. And I will discuss the hard problems or the difficult problems in the doubt session of the assignment as well. And I have tried that you guys should not only get the basics of the things or the topics we have covered in unit first, but we have also covered the topics in detail. Okay, so I think if you learn topic in detail, you don't need to remember them again and again. I think they would somehow automatically stored in your memory. Okay, so guys, this is about today's lecture. Let's meet in the next lecture. Thank you so much, guys. Have a good day.